Hi, my name is Bruno Caldas Viana, and I'm going to talk a little bit about GANs and their relation with art, still images, and moving images. And I'd like to start first talking a little bit about the history of GANs. They became really well known and popular in recent years, even in the art world, because in 2018, a painting by the French collective named Obvious, it was sold at the New York auction house, Christie's, for $432,000. And in Christie's own words, that made them the first auction house to offer work that was based on an algorithm. That statement is kind of dubious because the history of algorithm art, it begins long before this event, but it's still a kind of a groundbreaking event because this is not just any procedural algorithm. This image was made by a GAN, which is a specific type of artificial intelligence neural network, which is particularly good at generating fake images. But the history of GANs begins much earlier than that, and it's as interesting as the development of artificial intelligence itself. It can be traced back to even before computers existed, because the first model of a neuron was proposed in 1943, much before it could be actually simulated in a computer. Then in 1957, 14 years later, Frank Rosenblatt proposed to connect these simulated neurons in a network that would then resemble what a biological brain would be. And he actually tested this model on an IBM computer. And after testing, he built a hardware prototype of this that's named the Perceptron. This will be like a piece of hardware that combines light sensor, potentiometers, and they formed a mesh of fake neurons that would be able to classify very basic shapes like crosses and circles that were put in front of its eye, which is this grid of photocell sensors. And the development of AI has had all sorts of bumps in the way after that. One of them was caused exactly by the Perceptron, because one book by Marvin Minsky and Seymour Papert criticized heavily the Perceptron in the capacity they had to simulate for artificial intelligence. And that is also considered one of the reasons for the first AI winter, like a time when the development of AI slowed down in the late 60s. And that's really curious because the solution for the problems of the Perceptron was in this very same book. It was they proposed to create a multi-layer perceptron, which is nothing else than connecting the output of a perceptron into the input of another one, and so and so. And that's the same technique that's still used today in neural networks, even in the GANs. And over time, more of the puzzles of the development of the GANs were put together. Like in 2006, there began what's called the deep learning of networks, because this technique called greedy layer-wise pre-training was invented. And besides the evolution of computer power and memories were itself, they also helped a lot with the evolution of AI, because it allows us to create more complex memories with more memory that can be rendered faster. Until in 2014, this PhD student at the University of Montreal, Ian Goodfellow, he came up with this idea for a network that would generate fake images. And it actually consisted of two parallel competing networks, one that would be generating images and the other one that was trying to detect if these images were fake or not. And that's why it is called adversarial, so generative adversarial network. And of course, after this paper, they became really popular, but the evolution didn't stop there. Like the painting that was sold by Obvious was made with a DC GAN, which was published in 2016. And last year in 2019, NVIDIA published Style GAN 2, which is a really powerful software model that creates high resolution realistic images. There are many other techniques and to generate fake images with AI, even some without GANs, but we cannot focus on all of them. So I'd like to focus a little bit more again on the techniques of the GANs. I mean, the first thing that it's most importantly is required is to feed the network with hundreds at least, but ideally thousands of images that belong to one particular model, like cars, churches, houses. And these images, what happens today? They actually disappear into the statistical model of the network. I mean, they're never seen again. If one of these images would resurface, it's a sign that the network's poorly trained. Right? The fake images should, resemble the original ones, but not like be identified as the original one. So they actually disappear, and this disappearing act, it turns then into a very interesting case of the operative image. That the operative image is a concept that was proposed by Harun Farocki to describe pictures that do without the appreciation of humans. I mean, that humans are kind of out of the loop of production and watching the images. If you quote from this text, phantom images, he would say that these are images that do not represent an object, but rather are part of an operation. And he was thinking of the video guidance systems for weapons, like for missiles, where the missile would have a video feed that would be analyzed and then be used to guide the missile to its target. And then obviously these images will be never stored, or they will be destroyed with the destruction of the target, so they disappear again. But the GANs, they have the images leave some hubris, which are the statistical data of the model that's used for to create the fake images. So if we persist with the biological metaphors of the neuron and the brain, we can think of this data as some kind of a memory of the machine that's imprinted by the original images. So these still images created by GANs are really ubiquitous now. I mean, everyone uses them, from researchers to artists to people who create fake news. But with the moving images, it's the case is a little bit different, because some of the most popular videos created with GANs, they are explorations of the latent space of the networks. I mean, they navigate from one image to another one, doing a very beautiful morph, for instance, from a baby to an old man. But they're still created with still images. They do not represent the model of a static model of a video. I mean, fake videos are very common, but I can feed a network with hundreds of pictures of Obama, and then use it to create a fake video. But this fake video is actually based on a guiding video, which is a video of my face looking up, down, smiling, and that would make Obama look up, down, and smile, but it's still made from still images. This is also the case with other techniques like pix-to-pix, where you can replace a horse with a zebra and so on. But what I think the most interesting experiment in really trying to create a memory of a movie in artificial intelligence is the re-encoding of Blade Runner, which was made in 2016 by Terence Broad. He did not use GANs, he used an autoencoder. So he trained this model with the frames from Blade Runner to find the coherent information, and reduced every frame to a 200-digit number that when it was reconstructed, decompressed, it would create a version of Blade Runner that was eerily similar to the original, but not identical. Still, it was so similar that it would he got a copyright notice to take down the video because it was breaking copyright of the original one. Another interesting thing about this process is that according to Terrence's website, he does not the software that was used to create it, it's not available anymore. I mean, which is interesting. It creates this kind of an evidence of a technological development, but where the tool is not there anymore, but the evidence of the video remains. And this happens a lot with AI projects. I tried many times to recreate the experience that other people did, and sometimes with a project as recent as 2 years ago, I cannot do it anymore because the software is not available anymore. But in any case, I would like to wrap up this presentation with a project of my own, which is heavily inspired by Terence Broad's project. In this project, I start with a movie from Tarkovsky, which was a master in dealing with memory and nostalgia. And I picked up the movie Mirror, which is really deals with self-memory of one person. So what I did is that I fed the frames of the movie to StyleGAN 2 network. What's interesting about StyleGAN 2 is that when it was published, they also published a tool that was named a projector, which is ironic if you're working with movies, with cinema, but it has nothing to do with a movie projector. It's actually a tool that allows you to find the most similar image inside the latent space to a given image. So I could try to find if there's any face similar to mine in a network that was trained on faces, but it, of course, doesn't find the exact face, but something that resembles what you're giving to the projector. So after it was trained on the frames of Mirror, I actually went back to the same frames and fed them to the projector, but one by one, trying to find what was the most similar image that the projector could find. And I reanimated the sequence of frames. So I actually made, again, a version of the mirror from what this network, from what this machine could remember. It's, of course, it's a very imperfect render because, again, requires a coherent category, like collection of cats or faces. And even though Tarkovsky has a coherency of its own, like in terms of the color palette, framing, actors, this is far than sufficient for the GAN to create realistic images. So what this GAN can do is really just to create like this very faint mechanical self-memory of visual masterpiece that's about the memory of itself, of a self-memory. So thanks for listening, and I hope to listen to more stuff from the conference. Thanks for inviting me as well.